Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about probability. So the very first thing is that probability. So probability will have us uh, in real life events. So that include a sense of randomness and chance. So suppose if I'm going to uh, roll a coin. So what is the probability of getting a number and probability of getting head and tail? So what is the probability of getting head and then what is the probability of getting head and tail? So I'm going to have two chances. So probability of getting the tail is 1 by 2 and probability of getting the head is 1 by 2. So totally 1 by 2 plus 1 by 2 that should be 1. So similarly if I'm going to roll a dice, so what is the probability of getting 1, probability of getting 2, probability of getting 3, probability of getting 4, probability of getting 5, and probability of getting 6. So total number of chances is 6. So what is the probability of getting 1? So 1 by 6. Probability of getting 2, 2 by 6. Probability of getting 3, 3 by 6. Probability of getting 4, 4 by 6. 5 by 6 and 6 by 6. That should be 1. So like this, we're going to obtain the chances in real while even. So the probability plays a vital role. So the base when it comes to basics of this probability, so the definition should be so procedure. So procedure is nothing but an act that leads to a result. For example, throwing a dice or visiting a website. And procedure is nothing but an act that leads to result. So example just now what I said, throwing a dice and then visiting a website. And event is nothing but a collection of outcome of the procedure. So event is nothing but a collection of outcome of the procedure, such as getting heads on a coin flip and leaving the website after only the 4 seconds, like this. A simple event is an event of procedure that cannot be broken down. So a simple event cannot be broken down, and whereas the procedure can be able to be done in different events. For example, rolling the dice that can be broken down into two simple events, rolling the dice 1 and rolling the dice 2. And the terminology what we're going to be refer is sample space. So the sample space of the procedure is nothing but the set of all possible simple outcomes. An experiment is going to perform in which a coin is going to be flipped 3 times in succession. And what is the size of the sample space for this experiment? Suppose the answer is 8. So if I'm going to roll a 3 coins, so what is the probability of getting this? So one is all heads and another is all tails. So 2 heads, 1 tail, and 2 tails, 1 head, 1 head and 2 tails, 1 tail and 2 heads, and head, tail, head, and tail, head, tail. So this should be the sample space. So total is 8 for rolling the 3 coins. So the very first thing is that, so basics of probability. So the procedure is going to be acts that leads to a result. And event is nothing but a collection of outcomes of the procedure. such as getting heads or coin with or leaving the website, and rolling the dice that can be broken down in simple events. And sample space is the procedure that should be set up for the simple events. For example, an experiment is going to measure or perform when a coin is flipped three times. So if I'm going to have a coin, so tail, head, tail. So what is the probability of getting these flipped three times of a coin? So answer is 8. And probability is nothing but it is going to represent the frequency or a chance that event will happen. Okay, so the probability is nothing but an event. So that is going to represent the frequency or chance that the event will happen. For notation, if A is an event and P of A is the probability of occurrence of the event. So the actual probability of the event will be denoted as the number of ways A occur and size of the sample space. So probability is nothing but it is going to represent the frequency, a chance that the event will happen. For example, if an A is an event, so the probability of A should be the probability of occurrence of event. What is the actual probability of the event? So probability of A equal to the number of A ways may A occur and size of the sample space. So example, if our study has 100 people and A has 25 people, and the probability of A is denoted by 25 by 100. If our study has 100 people, right, in out of that, so A group is going to have 25 people. So what is the probability of getting A? That should be 25 by 100. And next one is Bayesian versus heuristic. So what is this heuristic approach? In a frequentistic approach, so the probability of the event is called through an experimentation. So it uses the past in order to predict the future chance of the event. Suppose if I'm going to take, I want to make a reservation for a train. So when I click this, so it is going to show what is the probability of getting the obtaining the seat. So it is getting showing as 80%. So similarly, class 3, if I'm going to click on this, so what is the probability of obtaining this, getting the seat in class 3A? So the frequentistic approach is one of the example where the probability of an event is calculated through experimentation. So mainly it uses the past in order to predict the future or chance of the event. So the basic formula what I'm going to follow here is number of times A occurred divided by number of times that was repeated. That is the formula you have to be remembered. Normally, this Bayesian approach differs from dictating the probabilities must be discerned through various theoretical means. Using this Bayes theorem, we would like to think a bit more critically about the events and why they occur. The crux of this frequencistic approach is the relative frequency. And the relative frequency of an event is how even an event occurs divided by the total number of observations. So the Bayesian approach differs by dictating the probabilities that must be discerned through theoretical means. And using the Bayes approach, we would like to think a bit more critically about the events why they occur. And the relative frequency of the event is how an event occurs divided by the total number of observations. So next one is this law of large numbers. So here the reason is that even the frequency approach can do this because the law of large numbers states that if you're going to repeat a procedure over and over, then the relative frequency probability will be the approach the actual probability. If I were going to ask average of number 1 to 10, so we would like to see 2, 3, 5. So the Python will be able to choose a random number between 1 to 10 and then we are going to find the average. So this is the one of the example of law of large numbers. So what is this law of large numbers states that if I'm going to repeat a procedure over and over, so then the relative frequency probability will be the approach of the actual probability. And next one is that conditional probability. So conditional probability means pick up an arbitrary person from the study of 100 people. Pick up an arbitrary person from the study of 100 people. Let us assume that the test results are positive. So what is the probability of getting actually having a cancer? So I told that if event has already taken place and the test came back positive. So we are told that event B is already taken place and the test came back. So the question is that what is the probability that they have cancer? So that is P of A. So then what is the conditional probability of A given B? So that should be written as probability of A by B. Okay. So we are going to have 100 people. So out of this 100 people, so assume that test result was positive. And what is the probability of having the cancer? So the event B already taken place and the text came back positive. The question is that what is the probability of A given B should be denoted by probability of A by B. So effectively it is asking to calculate a probability of an event. So that was already happened. So how can you represent the Venn diagram of this conditional probability? So initially we have a Venn diagram. So the probability of getting obtain A over B is represented as A. So what is the formula we have to be followed? So the probability of A by B, so you should be write it as probability of A intersection B divided by probability of. So the probability of A over B should be written as probability of A intersection B divided by probability of B. The probability of A intersection B is 20, so it should be denoted by 100, and probability of B is 30 divided by, so 30 divided by 100, so totally 20 by 30, that should be 0.6. So probability of getting A by B equal to probability of A intersection B divided by probability of B. So probability of obtaining A intersection B is 20 by 100 and probability of obtaining B is 30 by 100. So totally 0.6%, that should be 66%. Suppose we are going to have, so initially they give the values like P of A is equal to 20, P of B equal to 30, P of A intersection B equal to 1. If I give like this, so we're going to calculate. So for this, probability of intersection is 20 divided by 30, 0.6. What is the probability of B by A? So probability of A intersection B divided by probability of A. So A intersection B is 20 divided by 20. That should be 1. Should be 100%. So like this, we are going to calculate the conditional probability as well. So in a group of 100 sports car buyers and 40 bought alarm systems and 30 purchased bucket seats and 20 purchased an alarm system and bucket system. So if a car buyer chosen at random bought the alarm system, what is the probability they also bought the seats? So in a group of 100 sports cars buyers, so 40 alarm systems and 30 purchased bucket seats and 20 purchased an alarm system and bucket seats. So for a car buyer chosen at random, so what is the probability of obtaining the bucket seats? So for this function we have to write so that A is the selection of alarm system. So the probability of getting an alarm system is 40%, that should be 0.4. And next one is let B be the selection of bucket seats. So finding out what should be A intersection B. So A intersection B. So intersection of A and B. So both happening together. So in the given question, so 20 out of 100 buyers. That means so 20 people purchase both alarm system as well as the bucket seats. So probability of A union B, both A and B. So A and B equal to 20. So that is 0.2. And final answer, what is the probability of getting the bucket seats? That is probability of B by A. So probability of A intersection B by probability of B. So that is 20 divided by 40. 0.5%. Let's have another example like we're going to have some pets and don't have pets. So how many number of male people is going to have pets? Or how many number of female people are going to have pets? So what is the probability of randomly selected person is male given that they own a pet? So for that what you have to do? So repopulate the formula when the new variable so that it makes sense for the question and also helps to clarify what you are looking for. So I'm going to say for male, so PO stands for pet owner. So the formula becomes the probability of M by PO. So that should be probability of M intersection PO divided by PO. So figure out this M intersection PO from the table. So intersection of both males and females. Intersection of males and pets. And similarly find out probability of PO pets 0.86. So then write down the exact these values in the equation. So the probability of M by PO should be written as M by M intersection PO, that should be 0.41, and probability of M, that should be, so what is the probability of obtaining this? So probability of M by M intersection PO, so that is 0.41 divided by probability of obtaining M, so 0.6, so that should be 47.7%. So like this, we are going to calculate this conditional probability values based on the question. So the male in this question, the male is going to have 0.41% of pets, female is going to have this, and total of this should be 0.86. So what is the probability a random selection person is male given that they own a pet? So reformulate the formula with new variables so that it makes sense for the population. So I'm going to say that the PO should be the stands for Petomer. So the formula will becomes as probability of M by PO. Then it should be written as probability of M by PO divided by probability of PO. And next we are going to see about the rules of probability. So addition rule is going to be calculated the probability of either events. So the rules of addition rule is that so probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So if I'm going to take a single card from the regular pack of cards, so what is the probability that the card is either ace or spade? So if you take a card from a regular pack of cards, playing cards, so what is the probability of obtaining either ace or spade? So letter X is an event of picking ace and Y is the event of picking spade. So the probability of X should be 4 by 52 and spade is 13 by 52. So the total number of cards is 52 here. So in this one 52, then 4 ace will be there and then 13 spade will be there. So what I'm going to do, so the probability of obtaining ace is 4 by 52. Probability of obtaining spade is 13 by 52. And so what is the probability of X intersection Y? So both spade and then ace, what is the probability? So that is only 1 by 2. And finally we are going to get A union B. So for this A union B is A union B is equal to 4 by 52 and then 13 by 52 minus 1 by 52. So total I am going to get 16. That means 4 by 13. So 16 by 52. 4 fours and 4 13s. So this should be the final value. And next one is mutually exclusive rule. So we are going to say that the events are mutually exclusive if they do not occur at the same time. So that is A intersection B should be pi, or just that intersection of events should be empty set. If the two events are mutually exclusive, I'm going to say that the probability of A and B equal to probability of A plus probability of B minus A intersection B by the number of times minus P of A plus P of B. So some of the examples of mutual exclusive events is that a customer seeing your site for the first time on both Twitter and the Facebook, and this today is Saturday, not today is Saturday and today is Wednesday. I failed econ 1 and passed econ 1. So these are now mutual exclusive events. So if the two events occur mutually exclusive that cannot be occur at the same time, then at the time I can able to say A intersection B equal to pi. So A and B is equal to B of A plus B of B and of A intersection B. So some of the examples will be like this. So today's sentence Saturday and today's Wednesday like this. Next one is multiplication rule. So here this one is going to be used to calculate the probability of events. So probability of A union B equal to probability of A and probability of B. So the equation should be written as probability of A intersection B equal to probability of A into probability of B. So see the example here. So considering example. So let's redefine A to the event that rail is posed to, and B should be the person being cancelled. So what is the equation here? Probability of intersection B equal to probability of A into probability of B by A. So that is 3 into 0.6. That should be 20%. So probability of A intersection B is equal to probability of A into probability of B by A. So what is the probability of A here? So 3 into 6.6 is that should be 1. And next one, in another example, we're going to see randomly selected set of 10 people. So 6 people is going to have 6 iPhones and 4 is going to have Androids. What is the probability of selecting 2 people that they have both iPhones and then Android? So that every the event showing the probability that that we are able to choose the person with iPhone first. And similarly, the event B, what is the probability of obtaining the person with iPhone second time? So what is the equation here? So probability of A intersection B is equal to probability of A and probability of B by A. So the probability of A should be 10 6 by 10 into 5. So that you can able to get 3 by 5, that should be 0.6. So we have only the 9 people left to choose our second person from because one can able to take over. So in our new transformed sample space, we have 9 people in total. So the other 5 people should be iPhone and 4 thing should be the Android. So the sample space is that the probability of B is equal to 5 by 9. So that should be this one. And then probability of choosing 2 people with iPhone is that. So 0.6 into 0.5. And next one is impedance rule. So two events are going to be impedant independent if the one event does not affect the outcome of the other event. So the probability of B by A is the probability of B into probability of A by B. That should be probability of A. The two events are said to be equivalent. So some of the examples of independent event are as follows. If it was raining in San Francisco and Puppy was born in India, flip a coin and gets the head, and then flip another one, get tail, and none of the pairs of events that affect each other. If two events are independent, then probability of A intersection B is equal to probability of A into probability of B by A. So that should be simply written as probability of A into B. Since the two events are said to be independent, so I can equal write the probability of A into probability of B by A. That should be written as probability of B. So some of the examples of individual events. So it was raining, flipping coins, and getting pairs, and none of the pairs of events that even occur. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.